I'll present some more of the practical work that we are doing. So we do a lot of applied research, but also the implementation in the field. And I'll show some examples of where we're working and how we are dealing with the issues. So first of all, the soil doctors, we call ourselves a social enterprise, and our mission is really to improve crop yield under actual field conditions, but also put the solutions into the hands of the people who are really dealing with salinity, the farmers, of course. So we do a lot of salinity assessments, as you can see here, but also the teaching, the training, capacity building is always very important. And again, we do that from a very applied and practical point of view. We did a lot of research on the soil tolerance of crops. I'll show you that as well. But also the applied research demonstration in the field is always very important to us. And in the end, we're working towards the scalable solutions to really have the action and implementation in the field, of course. So a little bit of the background of our work, our knowledge. So we used to work for Salt Farm Texel, where we realized a very big open-air lab where we could do controlled testing on the field conditions. And actually, in all those years, we've tested around 800 varieties of 50 different crops. And our assumption was that if you test enough crop varieties, you will identify some varieties who have a higher level of soil tolerance than the common varieties that are being used by the farmers nowadays. And for instance, potato, it originates from the Andes. In the Andes, you have a lot of natural salt-affected areas. There are around 300 wild potato varieties, so they are adapted to salinity somewhat already. So if you can include those varieties into the commercial varieties, you can very quickly improve the salt tolerance of conventional crops. Well, based on all the research we've been doing, well, we actually found more tolerant crop varieties. You can look at our website for some scientific articles. But for instance, for potato, cauliflower, carrot, beets, those are very interesting crops for cultivation under moderate saline conditions. And also Kate showed the global soil salinity map. Well, actually the majority of all the salt-affected land in the world is only slightly to moderately saline. So then it makes a lot of sense to focus on these more robust varieties of conventional crops because they have a very good nutritional value, good market value. The farmers know these crops already. So then it makes a lot of sense to focus on these conventional crops and, for instance, not on halophytes that are very suitable for very high salinity levels. It was mentioned already before that salinity is quite complex, and even from an applied point of view, you cannot consider only the crops, but you have to look at the soil and the water component as well. And I won't go through all this, but there's a very complex interaction between your crop and your soil and your water. So there are a lot of different levels you have to take into account, not only to understand the local problem, but also come up with a very tailor-made local solution. And you can also look at prevention, mitigation, and of course, adaptation. And then you also have the scale, farm, field, regional level. So all these different aspects come into account if you're working on tailor-made solutions. And I was mentioning technical aspects, so your crop, your soil, and your water, climatic conditions, input materials, those are all the technical aspects. But to really have successful upscaling, of course, you also have to look at different socio-economic factors and in short, also look at the business model for the farmers, of course. Because all farmers, they don't like to take risks and they're all business people. It has to be profitable as well. So if you forget about that, then the solutions will not be very sustainable from an economic point of view. Well, understanding the problem, that's a lot of work that we are doing. It always starts for us with salinity assessments in the field, taking soil samples, really understand the type of salinity, which kind of salt, the concentrations, of course, but also understand the source of the salinity. Because if you understand all that, then you can really work on developing the solutions as well. How can you prevent salinity from becoming worse? How can you mitigate the effects? And how can you best adapt to it? So that's always starting with the soil sampling, and often this is a step that is easily overlooked somehow in the field. but really take good soil samples, understand the salinity, do quick salinity assessments is always the start for us. For instance, if your salinity source is shallow saline groundwater and you have capillary rise, in many deltas that's the case, well, drainage is of course the solution, but that can be very expensive investment for farmers. And you can also, for instance, look at trees, because they help to lower the groundwater level. And this is an example from Egypt, where we started planting a salt-tolerant tree species called Sesbania. So I'm not sure if you know salinity levels, but this is really high salinity levels. But Sesbania is a very salt-tolerant tree crop. And actually the difference you see here, it's the same location, but there's only 3 months difference. So it's a very fast-growing crop. And the roots take up the salty groundwater, lower the level of the groundwater, and with that you stop the source of your salinity of the topsoil. So that's always the start to help improve the local conditions. And in this case, we think it makes the most sense to work like this. But we do a lot of implementation all over the world in the really salt-affected areas, Egypt, Kenya, Bangladesh, Vietnam, Jordan, and here we are doing pilots on a relative small scale, so usually not bigger than 1 to 2 hectares. So we validate the results of the different crops, we look at the local conditions, start looking at the business model for the farmers, and also work on the best scalable solutions for further implementation. Some further implementation, we did it with potato. So one of the potato varieties that we tested in the Netherlands appeared to be quite tolerant to moderate saline conditions. And yeah, in Pakistan, just by introducing this other potato variety, the yield already improved by 42% for these farmers. So that's just by changing your crop variety, by adapting to the salinity. Very quickly you can start improving the yield. And the yields are they're really under pressure in these salt-affected areas. So year 1, 42% yield increase, you have a happy farmer for sure. A little bit same results in Egypt. Also under saline conditions, we tested 8 different potato varieties. And also there, yeah, 32 tons per hectare under moderate saline conditions. The national average with no salinity is 27 tons per hectare. So, and this is also organic cultivation. So farmers there are also happy with the results. We're also working on different brassica crops like the cauliflower and broccoli. So also very good nutritional value, good market value, and also quite tolerant to moderate saline conditions. Carrot, we do a lot with that. Here, for instance, you see a salt-tolerant variety that we introduced compared to the local variety. And there in Kenya, we more or less doubled the yield for that farmer. And here in Bangladesh, well, the farmer insisted of using the traditional method. Well, you see the result here. And this is based on our recommendations. And that's in the dry season when usually the farmers don't have any crop at all. So if you can introduce a new crop season to the farmers, well, there's a lot of positive effects with that as well. And you can see that this is the big Bangladesh project that we worked on together with ICO, Dutch NGO. We trained 5,000 farmers implementing the crop cultivation under saline conditions. And you see here, so none of the farmers used the salt-affected land in the beginning, so 0%. And now 3 out of 4 farmers are using the salt-affected land during the dry season. And then you see a whole cascade of positive effects. Now we're producing vegetables, so okay, they're eating more vegetables, but they're selling it on the market. There's a whole cascade of positive effects coming from improving crop yield under saline conditions that you can also link to the Sustainable Development Goals, of course. So in short, we identified specific crop varieties already, but there's still more research to be done for also heat-tolerant, drought-tolerant varieties under saline conditions and resilient farming practices. I think we have a lot of pilots already on a relative small scale, 1 to 2 hectares. We see very good results. You need to develop a tailor-made cultivation strategy. But then for the further upscaling, yeah, you really need to include more farmers, showcase it on a bigger scale, really showcase the business model for the farmers, showcase that it's a low risk for farmers, so you really have to be visible in the field. And also, of course, the sustainable use on the long term, so longer than 5 years. But if you develop that, we are confident that many salt-affected areas in the world have a very big potential to really improve food security in many different places in the world. And I'll stick to that. Thank you.
Thank you very much.